event. I'm Gonzalo Pastor. I'm one of the members of the Southwest Committee, and I'm also a senior associate for Hoare in the Bristol office. So this is the final session of our present and future offsite fabrication applied to building services event. And we're going to be focusing on more on the detail engineering innovations in the fabrication installation stages. So I'm going to hand over to one of our speakers, to Neil. We'll take off from here. The only thing is, if you have any questions, just write them on the chat and we will have a Q&A session at the end. Over to you, Neil.
Thanks, Gonzalo. Hopefully everyone on the call is return visitors, so you'll be well aware of who I am. But just as a reminder, my name is Neil Ross from Langer Ork, joined by Joe Lally, who's my colleague in Langer Ork too. This is the third session of a three-part series. The first session we focused on an introduction of what the DFMA process is in accordance with delivery of offsite MEP products. We introduced some benefits and considerations to be had in the delivery of those. And we also introduced some of the product set as well. Session 2, which was last week, we started to think about what the future would look like, what we might need to do to change our current processes to have a more streamlined and integrated solution moving forward. This session, session 3, as Gonzalo mentioned, is really about giving some examples of where we see innovation occurring within the digital space, particularly related to fabrication and installation stages. So last week was about design. This is more around the sort of tail end fabrication and installation stages. So we will, as I said, we've got a few case studies. It's not intended that this session will be overly long, so we'll probably whiz through it quite quickly. And it'd be good at the end of this session if we could have a sort of general thoughts and feedback from those listening and attending, just in any questions that might apply to each and every one of those 3 sessions. It'd be good to hear back from you. Okay, next slide, please, Joe. Again, so this is myself and Joe. If you want to read this back at your leisure, then you can do that. Our bios are shared on LinkedIn, and I think we'll probably be distributing the slide decks after these sessions anyway. You can read that at your leisure. Next slide, please, Joe. So again, for those of you who have attended the previous 2 sessions, you'll now hopefully be aware of who Langer Ork is. And for any of those who haven't attended the previous 2 sessions and this is your first session, I'll just give a very quick overview of Langer Ork as a business, so at least you have an understanding of perhaps where Joe and I are coming from. So it's a privately owned business. It's an international business as well. We've got world-class capabilities spanning the whole of the client value chain, from the start of a project all the way through to delivery and operation. Our mission is to become the recognised leader for innovation and excellence within the construction sector. We've got a mature digital engineering and design for manufacture and assembly offer, which I hope is coming through during these sessions. We do strive to improve productivity and product profitability, and we're continually developing with innovation and sustainability as a key focus. We've got 4 manufacturing facilities, primarily centred in the Midlands of the UK. We've got our Centre of Excellence for Modern Construction facility at Explore Industrial Park and Workshop, which is the most automated concrete products facility in Europe. We've got a GRC manufacturing facility in Doncaster. We've got a volumetric facility in Manton Wood. And last but not least, we've got our M&E facility in Albury, which is celebrating its 25th year in operation this year. I'll now hand over to Joe, who's going to touch on some of these case studies we've got for how we're using digital engineering in the fabrication and installation phases of the project.
Thanks, Neil. So, good afternoon, everyone. This should be a familiar slide from last week, so excuse me, I'd just like to recap on this one. And you might sort of think, what's this got to do with fabrication and installation? But hopefully by the end of this, you'll agree with me that sort of how important it is, and this is sort of the underpinning technology needed, and it's needed to make us head in the right direction if we're to improve the productivity of our industry, and how connected design and a data-driven approach will be the catalyst for this transformation. So I'm not going to go into masses of detail here, because we talked about this last week, but what this diagram is highlighting is the need for a data-driven approach that will enable us to drive some downstream sophisticated process. So on the left-hand side there, you see the data environment, And this is just one system. This isn't just one system. It's likely this is going to be lots of interconnected systems following an agreed and standardized structure like we spoke about last week. But the key here is to make sure that all of these inputs that go into this environment, the EIRs, AIRs, the specifications and so on, are machine readable, and that's really important. Now, if we can produce these elements here on the left-hand side, consistently in that machine readable format, then we begin to start to unlock some really sophisticated downstream process, which then does include some of the innovation in fabrication and installation. If we have standardized entities, for example, we can start making use of automated manufacturing techniques, for example. So a huge part of the inefficiency that we have to deal with on a day-to-day basis, as I'm sure all of you are aware, is this file-based approach to design and manufacture and assembly. So for the construction industry, I don't believe that the method for us conveying design and construction information has changed in a very, very long time. I'm guessing the Egyptians were creating drawings to create the pyramids. So, we've not really moved on. Today we're sort of using the same paper-based process for schedules, specs, and for good reason. Picture is probably the easiest way for us to understand an idea. And yeah, we can now create PDFs, but that's just a digital piece of paper. And we might have a few iPads out on site, but essentially we're using an iPad to just look at a digital piece of paper. It's not really groundbreaking stuff. And this paper-based approach means that we really struggle to read this information with a machine, and we're just creating masses of work for ourselves in the checking and reviewing process. So we really need to move away from this paper-based, file-based approach. And yet we still need to extract 2D information, just like drawings would have, because that's obviously very easy for us to understand. But it all must come from a centralized design model, this one source of the truth that can be interrogated and manipulated by both people and machines. So I'll just give a quick analogy of sort of the process that we've got right now, just to give you how, and I'm sure you're well aware of all this and how inefficient this is. So this is an example here of a door schedule that we get from an architect as a contractor. So this is 50 pages long. And this is originated from a design model. In fact, I know it has. It's come from a Revit model. So the architect has spent all of this time developing a design model that could potentially be interrogated directly. But instead, because of this status quo that we have right now, it's essentially printed out as a piece of paper. So then that has to be sort of checked internally by the architect for their sort of internal technical assurance process, and not machine readable, literally probably someone there with a felt tip pen marking it out, checking it against a drawing and so on. That's then issued to the contractor. Then we've got a person reviewing the same thing, possibly comment on it and going around in this cycle. This person has to then check internally for us, line for line, 50 pages, which in this case, this particular project, I have over 3,000 doors. And in that time, this person's like to be sat at a computer, maybe in an office, or ideally in an office, maybe at home now, but being distracted by someone in the office or the kids running around, for example, now. So just a very error-prone process and completely mind-numbing. Then, this is then issued internally via the contractor to our door supplier. They then create a piece of paper. They have to do the same process as review it. More pieces of paper. This is then 24 pages long. This is then sent back to us and checked internally again, and so on and so on. You can see they're just creating loads of paper and loads of no consistency. Across these three schedules are essentially the same thing, one being the door quote, one being from the architect, one being the as-built. Even the headings on some of these columns are all different. So there's just no way this is machine readable, very error prone. And this is just for the doors. I mean, we showed you last week that one of our healthcare schemes had over 1 million components. So you imagine the size of the task and the amount of people required, how error prone that is. This isn't a people problem, I'm not pointing any fingers here. The people in our industry are very competent people, experienced people. But just the scale of this and our wasteful, inefficient process just means that things get missed. So if we just go to how we think this could be improved, and this is, we think the whole process needs to be data driven, as we've said. And what we think we need to start doing is seeing our design models as just one big database. So people tend to focus on the 3D geometry, and yes, it's important. We need to make sure all things fit and they coordinate. But this is just one part of the design. The data is probably the most important part, I think. And And until now, most of the data is kind of an afterthought, or at least distributed in 3, 4, 5 different places. You know, some of it's in the model, some of it's in the drawing, some's in the schedule, some's in the spec, all of which right now aren't really linked together. And what we're also aware of now, most of you are probably already aware of this, have already discovered this as well, is that a lot of the design tools are not suitable to hold vast amounts of data. I'm not naming any names, but sort of trying to cram thousands of properties into some of these design authoring tools is not the way to go. They're just not designed for it to work effectively. So what we need to start looking at is what we're suggesting here. So it's the integration of design authoring tools and suitable data management platforms. So specifically to hold, you know, that's built specifically to hold vast amounts of information, and this is where certainly our future efforts are being focused at the moment, and this is just a bit of a mock-up of how this might work. So, you know, on the left hand side, designers producing information like they do right now, albeit using open data standards such as IFC, and all of this is hosted in some kind of cloud-based common data environment, most of which these days have APIs, which stands for Application Program Interface, and this is essentially part of the system that enables it to talk to another system. And in our case, what we're doing is linking this, you know, the federated design model to a database, and this is done in simplistic terms by the use of a key. You know, so the model element contains a key or an ID, and as long as the tabulated data that sits outside in the database has the same key, the two things can be linked together and then pushed into things sitting on top, like a model viewer and some kind of business intelligence. So essentially, you can actually see, you know, model and data together, but not, you know, the data doesn't need to sit basically inside the models. Vast amounts of information can be held outside and kind of brought together in systems that are suitable to do so. So this is just sort of a high-level overview of some of the enabling technology, and I'm going to run through a couple of the tools and processes that we're either looking at now or reviewing in our R&D team. So for the first one is the Autodesk Forge platform. Other similar stuff's available like 3D Repo. So I'm just going to go on to this video, so bear with me a second. So all of this stuff we're about to see here is all available on Autodesk's free demo website, so you can go in there and have a play with it yourself. But what you can see here is a design model and 2D extraction from that, and some kind of BI. But you can see here that all of this is linked together. You can filter out the design, the data, and the drawings all from the same place. This is essentially all the information that you'd see on maybe a schedule, a drawing, or potentially even a specification. You could bring all into one interface. So there's no need to create these masses of information. It should all be integrated and brought together into this one thing. And just to prove that this is sort of scalable, this here is some kind of processing plant, which is sort of a very vast and complex system. And you can see again that all of this here is, you know, data driven, and you can start chopping and analyzing this all from this one system. All based on the same cloud-based technology that we've just sort of discussed a second ago. And eventually, you know, using the same system and the same technology, we can also start to drive, you know, manufacturing, industrial robotics. So not only can we use this to sort of design and analyze, we can also then use it to start producing, you know, things automatically, you know, in the manufacturing center. So that's that one. Next, right, so in terms of how we can start using some of this in practice, as we discussed last week, so our DE team, or digital engineering team, currently produce you know, the design and the models for over 6,000 products a year. And this is an example here. This is a pump skid, and this is like a horizontal distribution rack. So right now we have a large team who produce the design for thousands and thousands of these things, all very traditionally. And you know, look at the hours there, it's absolutely massive. You know, over 6,000 hours a month, 73,000 hours per year, so a huge operation. So what we looked at maybe a year or so is that, you know, how do we improve that process? So what we looked at really was similar to the way you can in the automotive industry. I can go online and configure myself a new car or Range Rover or BMW just by clicking a few things on a website. So we thought, well, why can't we do that for our DFMA products? And again, I've got a short video just demonstrating this technology in action. So, but is the video all coming through okay? Neil, could you just, yeah, brilliant.
Yeah, it's coming through fine.
Right, this one doesn't seem to want to play, does it? There we go. Start again. Is this one okay? Yeah, cool. Right, so you can see in the Revit environment. So rather than our guys traditionally modeling stuff, we thought, why can't this be sort of parametrically driven and just with a few drop downs? So you can see here, this is an example of how you could build a system that could, just using a few drop downs, reduce the errors, because we kind of define all the engineering rule sets and everything behind the scenes. So our team now can just configure one of these modules using defined inputs. So you can see here they're starting to put chill water onto the system, checking all the spacings. There's logic behind here, so you can't put stuff on top of each other and so on. So you get the idea. Click through, and again, more importantly, this is then saved into the cloud and then transferred then into the authoring tool. And you can see here that creates a module. Sort of, it makes the perfect module every time almost. You can see that then is developed that in 3D, and you can go back in and tweak things where necessary. So a key metric here, it typically took or takes our team around 5 hours to design one of those modules traditionally, and using technology like that, we can sort of reduce that to literally a matter of minutes. So this is big savings to be had for this sort of configuration technology. Okay, so similarly to the process of modeling, right now our team will model these things, but then they'll also then produce many hundreds or thousands of manufacturing drawings for each of these things, and that again is just to convey the design to our guys in the factory, on the shop floor, what it is, and the schedule and bill of materials, how it's put together. And they would use these paper drawings out on the shop floor to develop that. So again, thousands of drawings, 24,000 hours of drawings time per year. So again, we were looking at technology that could, how do we stop doing that basically? So what we found, again, using similar technology that we found before, why can't we just send the 3D file directly onto the shop floor and enable the shop floor with some, model viewer technology, and try and make the manufacturing center drawingless? And we're sort of in pilot with this at the moment, and this is sort of working really well. What we did think was the guys on the shop floor might not want to transition from drawings, but as soon as we showed it to them, they were absolutely loved it. So again, I've got a quick drawing showing a bit of design automation and manufacturing, paperless manufacture. So Neil, could you just give me a heads up? Has this come through okay? Yeah. So you can see here, this is one of our modules. Traditionally, what our guys would have to do is kind of select each one of these. You can see here, this might be, I don't know, chilled water flow and return. And what they'd have to do is sort of break these up into, it's called a spool for those of you who aren't in manufacturing. So one spool might be this individual run for the flow, and another spool, individual piece that gets welded together for the return, and so on and so on. So they'd have to kind of define that in the model, and then sort of break that out into different drawings to show this spool, that spool, the frame, do all the dimensioning, all that kind of stuff. But what we've developed now is using a bit of design automation. So using a bit of Dynamo, we can select this thing, tell the machine this is a module, and it does all of the spooling automatically. So that all of that is done rapidly within a few seconds, which probably take a good few hours to get to that point. This is then published up into the cloud onto a system called Stratus, which is a US-based company called GTP, which developed this. And you can see now, again, using web-based viewer technology, we can go in and we can actually sort of filter stuff down. Here's all the frames, here's all the pipe work and so on. But importantly, what we can do now is produce digital drawings almost. So the information that used to be sent into the manufacturing center, rather than it being on a drawing, is now based in a model. Create lots of bills of materials and all that stuff rapidly as well, which I forgot to mention. But here you can see right now, we're zooming into this module. So this is the module itself, and you can see now that this is basically all the information you could ever want on a drawing and more, because the guys, for whatever reason, sometimes when we're modeling, we can't put all the dimensions on, or stuff gets missed, or very manual. Now we're putting the power in the hands of the guys on the shop floor. It can produce automated drawings if we want it to. But I think the drawings will actually just never be used, to be honest, because what we're doing is putting the power into the hands of the guys on the shop floor. They can interrogate this, whiz around it, get the dimensions, the schedule, all from a few click of a button. You know, a few iPads and a few screens just strategically placed in the manufacturing centre, and all of this, and it just saves masses of time. All the drawing information that we used to produce just goes away. So yeah, that's an example of how we're using the technology we spoke about. So I think for me that's it. I'm just going to hand over to you now, Neil.
Okay, thanks, Joe. So hopefully Joe's done a good job of explaining the need for the common data environment, or the central repository for the data. So rather than using conventional BIM tools, if you like, to hold the data, we're trying to move to a position where we're managing the data of all of our project delivery products and business systems all in the same place, so we can gain value of using the same data for different multiple uses. I think when we move to that place where we're starting to capture data, it does open up a lot of opportunity in terms of how we can be more efficient towards the latter stages of the construction cycle. So in the installation, manufacturing, commissioning stages, we can gain a lot of value through the better use of data. One thing that we're starting to explore is how could we use data and analytics around that data to help us drive a more effective commissioning process. What you see on screen is what we would typically experience. So we've got an installation, testing and commissioning process which is well defined and it's robust with strategic gateway points before we can complete through to the next stage of the process. However, what we experience because of delays and changes to design that we all experience as we go about our job, we end up seeing activities push through from installation into the pre-commissioning stage. So that therefore means that we experience a compression of the commissioning programme, or we experience stress on how the systems can be commissioned. What we've seen at the back end of that is once we start seeing the slip of the installation and testing works, we actually see the ability for us to complete our environmental tests and performance optimization at point of handover. We find that we experience that being quite difficult to achieve and in the way that we'd like to. And typically what we experience is that those activities will pass through into the defects and liability period. So it's not really giving the client a good position because they're going to have contractors on site trying to complete the performance commissioning of the systems. But equally, it costs the contractor a lot of money to send individuals back to site to have them complete the works, which we ideally try and complete before practical completion. In addition to that, what we actually do, we end up dealing with a lot of equipment faults and equipment defects during that defects and liability period. So again, it's a costly process for us as a contractor, and also from the client. It's not ideal that they experience these equipment faults post PC, if you like. So what we're trying to do is use the data which we capture from the process and from the systems to help drive a better way of getting to the point of PC with a completely completed solution. So really enabling us to complete those tests, optimize the performance of the asset as we could do to our best of our abilities before it's occupied, and equally identify any equipment failures and faults before we hand over. So we're investigating a solution to help us through that. So if you move on to the next slide, Joe. And I guess that's the link in terms of this session, not necessarily the linking through in terms of digital engineering, but better use of data, if you like. So what you see on screen is really just a very high level graphic of what our conventional commissioning approach is. We would typically go through our process, we'd be identifying failures or out of tolerance conditions, and we'd be manually resolving those. So we'd have operatives searching for those failures in the system. They'd be going up steps, they'd be going to plan, and they'd be trying to identify and resolve. Clearly that takes a lot of time, and it takes up a lot of our commissioning resource resolving issues that perhaps we could have a better way of identifying. Next slide, please, Joe. So what we're looking at is if we wrap around an analytics solution around the conventional commissioning process, we can actually drive data into the process, and we can drive advantage through increased productivity as a result. So using data analytics platform, the ones mentioned on screen, there are many others. we can use these tools to extract data from either the BMS or from the business systems, and we can use that to create correlations in how we think the system should be performing at that stage of design and that stage of assembly, if you like. And using different commissioning methodologies such as connected commissioning, functional performance testing, and fault detection and diagnostics, we can actually be in a better position as we go through the commissioning process using the data to help us drive towards a more complete position at the point of handover. So really using data shouldn't necessarily be seen as adding more noise into the process. We're actually trying to use data to help support our current processes, to drive the productivity gains that we need as an industry to help us deliver better, and equally ensure that when we hand over a building, we know that it's commissioned correctly, we know that it's operating in the way that it needs to operate, and then we don't have the sort of poor response feedback from clients of being delivered a project that's not working in the way that they hoped it would have been when they defined the project at the start of the process. So that kind of wraps up the case studies that Joe and I have taken you through as part of this final session. So hopefully, well, I suppose I did say it'd be quick. We have got through that in about 25 minutes or so. So hopefully it's not been too quick for you. I'd like to hope that through these 3 sessions you've gained an appreciation for what a DFMA process is and how we can establish MEP offsite products within our projects. I hope you can see the gains that we could experience across the full remit of stakeholders in the project. I hope you can understand how we can drive those benefits into each and every one of those stakeholders. And finally, I hope you can leave these sessions with a bit of a positive spirit around you to understand that the industry is changing, and there's a lot of technology that's enabling that change. And I think moving forward, we've got a real opportunity to make significant step changes in productivity of our design and construction operatives. And I think it's a really exciting part of the journey that we're all undertaking within the construction sector. So I will thank you all for attending. I'll hand back over to Gonzalo, who will field any questions that you may have.
Thank you, Neil and Joe. Yeah, anybody has any questions? There are not any at the moment in the chat, but feel free to ask any. When Joe was going through the spools drawings, it reminded me when I was working on the Westgate Shopping Centre in Oxford with Lang O'Rourke, and by mistake I was receiving all the spools drawings to review, and there were so many thousands of thousands. I was thinking, who can be reviewing all this? And like,
Did you give us statuses?
I was like, please don't send this to me. It's like, yeah, even if they're all great, it's still 5 minutes to say this drawing is okay. It's just 5 minutes time 2,000 drawings, 3,000 drawings, or whatever. It's just so long. It's ridiculous.
And it's the process is massively inefficient because it's we do have stuff like A-Site where we can publish digital versions of drawings, but people are printing stuff out, and it is crazy. Someone's got to create that, check it, publish it, then someone has to print it. Sometimes it goes to an external printing company to print them, and then if anything changes, then the whole process starts again. It's just crazy, isn't it? When you lay it out like that, it's madness what we're doing.
At that time, I think you couldn't mark things up directly on A-Site. So yeah, we were printing stuff, marking it up, scanning it, and then uploading. So yeah, it was like really time consuming.
Yeah, it's crazy, isn't it?
Yeah.
I think everyone's in stunned silence today.
Yeah, maybe you just want to call it a day then, Gonzalo. Oh, actually, here we go. One's come through.
Are consultants ever creating the services distribution models, or are Crown House, Lang O'Rourke reworking the consultants models to suit the skids?
It's a bit of both. I think sometimes consultants are employed to take things to a higher level of detail, but typically, yeah, our guys would take ownership of kind of major distribution routes and major parts of the plan. Anything that's being sort of manufactured in our facility would potentially be reworked by our team. I think we spoke about in one of the earlier sessions about in the future it's better to maybe have this sort of blended responsibility. You know, if we know that if we're on a project and we've been appointed, I think in the future it'd be good for us to agree early doors who's responsible for designing what, because there's no point in the consultant, you know, going to that level of detail, wasting all that time if we're going to then rework it. So for stuff like major distribution routes and plant rooms, I think, you know, we should have this blended responsibility in the future. I think just to add to your point, Neil, I think, you know, traditionally, I think contractors are seen as we having this sort of adversarial sort of persona. I think now we're trying to be as collaborative as possible. So we really want to engage early and collaborate early to make sure that we, you know, we save, you know, we're all efficient basically. We're not wasting time. So.
Yeah, on this topic, in the previous revamp VG6 document, I mean the stage 4, the detail design stage was split between 4A, 4B, and 4C, and normally no consultants just stop at 4A, which is before you you choose the final product, and you don't enter into the putting all the breakage and all that stuff, or more like an installation type of drawing. Now there are still some consultants that do, well, now it's called different with the new VG6 is 4I, 4 double I, for triple I, and they're trying to have a bit more more fluid detail design stage. But some contractors still prefer, and in the recent years, some contractors have decided to omit part of the design team as well. So there are some contractors are asking consultants to do that part for them. So it depends a bit. It depends on the contractor. They have different strategies. But yeah, some consultants never get close to this. Some consultants is just the bread and butter, and they do it every day because that's what they're specialized on. There are many more questions now. Well, I think this one is for very good presentation. Yeah, can you explain a bit more on the analytical data solutions and commissioning stage, Neil?
Yeah, I probably didn't explain that as effectively as I should have. What I'm effectively saying is that we can use, or certainly what we're exploring at the moment, we can use, for example, BMS data coming back from the system. We can use that BMS data to give us an indication on how well the systems are coming together and how well they're performing in line with the design targets and the commissioning targets. If you could imagine that we've got, traditionally we'll have a commissioning engineer who will be testing various points in the system, and they'll be looking for certain levels of feedback or certain performance targets at each of those points. What we can do is we can codify the subject area knowledge, or the expert's knowledge, if you like, into a rule. We can codify that rule, and then we can run it against the data that's been extracted. So we could really use a set of rules that will be running 24 hours a day autonomously in the background. It'll be randomly checking, or not randomly, it'll be continuously checking for any failures. So it might be if you're operating a fan in a fan coil unit and you're expecting to see some airflow or change in temperature coming off the back of it, but you've not got the fan operational and nothing's happening, you can write a rule to identify a condition. So effectively, it saves the commissioning engineer from having to go to the physical unit to do the check. But equally, as we progress through this, we could use alternative technologies, valving technologies, for example, to enable an automated commissioning process. So the BMS data will spit into the analytics package. An analytics package will drive an insight based on a rule, which will then feed back a condition to the BMS to enable it to change its performance values or change its set point limits or whatever it may be to hit the commissioning target. So it's really about taking the data from the BMS and adding that back into a rules-based analytics platform that allows you to codify the knowledge of the expert and therefore give the commissioning engineer a list of insights in graphical format, which they can then use to understand how the system is working and what needs to be done to get it to hit the correct operational limits. Hopefully that's not confused you even further. I probably should have pulled a video together, if I'm being honest. I think Joe's clearly outdone me on the presentational style.
So there was one question now about, yeah, sorry. I had something there. No. There was one question about the recordings. I need to get back to you on that. I think it's on the CIBSE Southwest or on the CIBSE YouTube channel. I need to check that, but they will be all uploaded there. Then we have one question from Claire. I think this is a good one. How are you dealing with change management when there are no physical drawings, there are no revision 1, revision 2, revision 3, and things like that?
Yeah, definitely. So we have thought about this. It'll be the model file itself that will have to have some kind of status and revision on it within the CDE. If we're generating it all from this centralized system, it will be the model file itself. There's almost like your paper drawings are now stamped with a status and signed off. It will be, you know, the centralized design model, and the data. The data will also need to be time stamped. You know, we're getting into the weeds a little bit here, but when you sort of produce a database, one of the columns could be a timestamp or a status and so on. So we'd have to some way, and we're looking at this, of making sure that all the different model files that are brought in are all status, and then all the various different data sets again are all status and all joined together. But yeah, it's a very good question. But yeah, dealt with, but similar to the way you do a drawing. Just the design files will be stamped similar to the way drawings will be.
Next one, I think we touched on this more in the last week presentation. What is the process from design stage model to the site project, then to offsite team with regards to the value engineering? I think that depends a little bit on traditional process or a bit more on more modern workflow. Purely, yeah. Do you want to, Neil, Joe, or do you want me?
I've got a little bit to add to this, and I think, like you said, we did touch on this very early. I think if we can get to the point this is in the future, not right now. If we can get to the point where we know up front and all this design is connected, certainly as a contractor, if we know, for example, we're building, I don't know, 3 or 4 schools or 3 or 4 hospitals, if all that's structured and all consolidated, we can sort of bring that into a huge database, and then we can understand, right, in the next 6 months we're going to need to buy, I don't know, 5,000 doors. So we can then go out to the market and have some certainty about the products that we're going to buy and get good price, a very good price on stuff. So that there might not necessarily be any need for value engineering in the future because of the way it's put together. We want to try and make sure the value is added early on by knowing and giving certainty to the supply chain and to us. I think we could try and not say get rid of it, but it's done very early on. So by the time we get to the design being completed and on site, there's no point for it because we've done it right at the beginning. We kind of pick the best price right from the beginning. I don't know if you've got anything else to add to that, Neil.
Yeah, I think that's right. I think VE or value management processes and projects are often driven by perception, and perhaps the client or otherwise, or the QS perhaps looking for what they feel is best value from a commercial perspective. And I think that's often born out of not having access to data to back up the justification for a number. I think what we are suggesting is that if we have a data-driven approach, just as Joe's mentioned, where there's more clarity in the material and labour build-up, because we've inherently got that through the increased complexity and understanding of how the products come together, then we'd hopefully get to a position where we, at the early design configuration stages, we can get a very rapid understanding of cost. So during the sort of stage 2, stage 3 levels, or design stages, we can go through those optioneering on cost. So by the time the contractor comes on board, from a contract perspective, there's not a need to then tweak the design to achieve a commercial target. So I think it's about the industry evolving in terms of what it's trying to achieve from a VE perspective. But equally, I think the process that we're advocating will drive better behaviours around VE and VM, because there'll be more robustness around the numbers that are committed to as part of the contract, if that makes sense.
Yeah, I completely agree. There are 2 different types of VE. One is more, at the beginning, during the design stage, the design team is just doing the design, and the QS is there checking that their estimated cost plan is still aligned or not. And that's just exactly what Neil said, is a bit of not having the information. And that can definitely you can get rid of most of it by engaging the contractor early, or just going to a more modern way of working, or more modern workflow. The other value engineering part is more, sometimes a design team just get their heads down, stuck into a brief, they just do their own thing. And sometimes you get this fresh air from a contractor or a third party just saying, thinking outside the box, saying, why don't you omit, if you omit 2 floors, you just get this massive saving, not only by omitting the 2 floors, because you make everything more efficient, everything easier to build. And that part maybe is still going to be there, but obviously what you will avoid is having this situation when you tender a project and then you realize that the estimations from the QS weren't right, and suddenly you just need to make all this apply all these V solutions, because basically it's not buildable for the money that you really have. Okay, we have more questions there. One for Joe on the 4th.
Yeah, I can answer that. And yeah, good to hear from you, Alan. Yeah, so we have been doing a bit of internal development on the Forge platform, and bits and bobs of Dynamo and all that kind of stuff to automate pieces. But we have also tried to focus on stuff that you can buy off the shelf. Some of the stuff you saw there, one of them was a tool from a guys called Kadak, who developed some of the configuration technology. Stratus is from a company called GTP, who are based in the States, and that's sort of free to, well, not free, but anyone can go and get that software and implement it. But yeah, it's just the underlying technology here is all very similar, whether it be Autodesk or Bentley or another provider. They're all shifting towards the same solutions, which is all cloud-based, with an API that will enable us to sort of bring the design into this centralized thing that we can then talk to and interrogate and bolt on various bits of data. So yeah.
Then Julian just confirmed what I said before. It will be in the CIBSE YouTube channel, where you'll find the recordings of this. Okay. Neil, on the commissioning, back to the commissioning. Does it generate a need for more control and auto balancing equipment in water systems, particularly? You responded to that, sorry.
Yeah, I responded to in the chat, but yeah.
Yeah, I think that's good. Any other questions? No.
Well, just if anyone thinks of anything after, I'm sure if they want to send some emails out to us or whatever, or maybe respond to is there going to be something from CIBSE, Gonzalo, in terms of feedback?
Yeah,
if there's anything, just happy to answer.
We are going to send us a feedback form. It will be just I think a single feedback form for the 3 sessions, and we will have some particular questions about each of them. So it will be great if everybody can respond to that. It will be really useful to know what you thought, or which areas this session really gave you a good overview of this, or there was anything else that we had to touch on, or if maybe there is something. I know that some of the ideas we were showing in the last week and this week, some of them might be quite radical, and people will say, "Oh, I don't see that ever working." I mean, that's the kind of thing that it will be really useful for you to provide your honest feedback on this. So I will probably circulate that by the end of this week or early next week. Okay. So. Cool. Thank you everybody for joining us for this event. It has been great, and they're having quite a lot of people joining each week, which is really, really good. So yeah, thank you very much. Yeah, we're looking forward to maybe doing something slightly different in the future, or some more events. We'll see if I can convince Joe and Neil.
Sure, we'd be more than happy to do something. Might have to give us a bit of a break, but yeah, sure, we'll be happy to do something again.
Good.
Yeah, thanks, guys.
Yeah, thanks very much.
Thank you, everybody. Cheers.
Bye.
Cheers. Bye.